Hello friends, welcome to Shiva Sai for You Basic Electrical YouTube channel. In this video, I am going to explain a solution for assignment 3 NPTEL course. Subject is network analysis. We can solve first numerical. So they given 180 volts and 44 Henry inductance, 40 ohms resistance, and switch is closed at t equals to 0. Capacitance value 1 by 440 farads, and voltage across the capacitor they given as V of t volts. So we need to find I of t and V of t coefficients. Okay, what is the current passing here? I of t, and then voltage V of t across the capacitor. They given equations. I of t equation is ai plus bi e power minus 1t plus ci e power minus 10t amps, and V of t is av plus bv e power minus t cv e power minus 10t. So this is what the given current equation and voltage equation. In this we need to find these coefficients ai, bi, ci value, av, bv, cv values. And however they given some condition here. The switch is closed at t equals to 0. Before that the above circuit was in a steady state. So before the switch was closing, earlier it was in steady state condition and the capacitor was uncharged, means not charged. For t greater than 0, the current I of t and voltage V of t can be expressed like this. So we can solve this. So apply KCL at this node. What KCL states? Entering current equals to outgoing currents. Entering current is I of t. Outgoing current is voltage by this current in 40 ohm resistance, and voltage by this or else voltage across the capacitor. Okay. So with that we can write it here. I of t is equal to V by 40 plus what is current passing to the capacitor? C dV by dt. So C value is 1 by 440 dV by dt. That is one case. Next is we need to find what is voltage at this point. Supply voltage minus drop in the inductor. Okay, this voltage minus drop in this is the remaining voltage, is the voltage available at this point. So that is written as 180 minus 44, that is 180 minus what is voltage across inductor? L di by dt. Okay, 180 minus L di by dt equals to V of t. So now 180 minus 44 d by dt, write as it is. In place of current you write this equation in place of current, that is V by 40 plus 1 by 440 dV by dt equals to V of t. So now in this, so 180 minus 44, I taken in these two terms 1 by 40 as a common factor. 1 by 40 take a common means you will get dV by dt first term plus 40 into 11 times you will get 1 by 11. Okay, d into d square v, dt into dt dt square. Okay, we got like this is equal to V of t. So now 44 by 40 you will get a 1.1 minus into plus minus d1 minus 1.1 dV by dt minus into plus minus 44 by 40 into 1 by 11. If you do this, you'll get minus 0.1 d square v by dt square into V of t. Okay. So now divide this coefficient of d square v by dt square. What is the coefficient of that? Minus 0.1. Divide the entire equation by minus 0.1. By doing that, 180 by minus 0.1 you get minus 1800. Minus 1.1 divided by minus 0.1 you get 11 dV by dt. Minus 0.1 by minus 0.1 you will get a plus d square v by dt square is equal to, now here also V of t divided by minus 0.1. 1 by minus 0.1 is minus 10. Minus 10 V of t. So now minus 1800 I am taking right side, it become plus 1800, and minus 10 V of t taken to left hand side, it become plus 10 V of t. Now we got a equation d square v by dt square plus 11 dV by dt plus 10 V of t equals to 1800. So this is a polynomial equation. So if I find the roots of this equation, see while finding the roots of this equation, you take the coefficient s square plus 11s plus constant. Only for this you find the roots. Okay. So the roots of the equation you will get minus 1 and minus 10. Now then you can verify the same should be the roots in the given equation. What is the root of I of t? Minus 1, first, that is the first root, and another root is minus 10. So we got the same roots. So now how to find the value of AV? See, you take the constant V of t is equal to 1800 divided by 10. So AV is 1800 by 10 is, we will get 180. You will get 180. Now assuming that now V of 0, okay, V of 0 means when time is 0. So when time is 0, when switch is closed, or when time is 0, voltage is 0. Voltage at that particular point is 0. When t is equal to 0, let's see what happens. you will get AV. E power minus, put t equals to 0. E power minus 0 is 1. Okay, now put t equals to 0. E power minus 0 is 1. Okay, so by putting t equals to 0, e power minus 0 is 1. Yes, you will get AV plus BV plus CV, and that value when V of t at t equals to 0, its value is 0. Okay, because they given for t greater than or equal to 0, current I of t and V of t can be expressed like this. But at t exactly equal to 0, the switch is closed. Before that, the above circuit was in steady state. Steady state means inductor will be short circuit and capacitor will be open circuit. Okay, so so with that condition, we can write now V of 0 is equal to 0. Then we get, see, this become BV plus CV and plus AV equals to 0. Taking AV right side, then that become minus AV. BV plus CV is equal to what is actually AV? 180. So BV plus CV we got minus 180. Take that as equation 1. Now again C dV by dt. C dV by dt is equal to I of 0 minus V of 0 by 40. Means we are taking the first equation in this. Okay, C dV by dt is equal to, okay, I of 0. You take this to left hand side, it become minus V of 0 by 40. Means we are taking initial current at t equals to 0 only. So that's why we written V of 0, I of 0, V of 0. Now from this, dV of 0 by dt, dV of 0 by dt is equal to, cross multiply this, 440 will come to this side. 440 into I of 0 minus, what is V of 0? V of 0 is 0. 0 by something is 0. Therefore 440 into I of 0 you will get. Again, dV of 0 by dt is equal to 440. What is I of 0? Okay, see, I of 0 is, the switch is closed at t equals to 0. Before closing the switch, the circuit was in steady state. So therefore at steady state, inductor is a short circuit. Then what is the current I of 0 at that condition? I is equal to V by R, 180 by 40. That's why we written I of 0, 180 by 40. By simplification, you will get 1980. So therefore, we can write minus BV, okay, minus BV minus 10 CV is equal to 1980. Okay, or else we can write BV plus 10 CV equals to minus 1980. So by taking a constants. Okay, got it. So from that we got equation 2. Now solve equation 1 and 2. See, you should analyze how I wrote this. Minus BV, okay, minus 10 CV is equal to 1980. How I written this? See how we got this equation, minus BV minus 10 CV equals to 1980. That is important. See, dV of 0 by dt is 1980. Means we need to differentiate the voltage equation with respect to time. Whatever the equation given in the question, V of t, dV by dt. If I differentiate, constant is 0. So e power minus t is minus. This become minus BV. Okay. And this becomes e to the power of minus 10t is, you will get a minus 10 CV. Okay, got it. So just I am writing only the just one time differentiation. Okay, that is minus BV minus 10 CV equals to 1980. So multiply minus on both the side. So you get BV plus 10 CV minus 1980. Solving equation 1, BV CV equals to minus 180, BV plus 10 CV equals to minus 1980. By solving that, we get value of BV 20 and value of CV is minus 200. Okay. Now you can represent V of t equation. What is the value of AV? 180. AV plus BV e power minus t, BV is 20, plus CV e power minus 10t. E power minus 10t is there only, minus 200. Okay, this is the actual V of t equation. So what is our AV value? 180. BV 20. CV minus 200. Again, now I of t is equal to V by 40. Again, I am taking the first equation. 1 by 440 dV by dt. 1 by 40. V, I am writing V of t equation. This entire thing. 180 plus 20t e power minus t minus 200 e power minus 10t plus 1 by 440 d by dt into V is there. 180 plus 20 e power minus t minus 200 e power minus 10t. So now So same thing I written once again here. So you can check out. So that is I of t 1 by 40, 180 minus 20 e power minus t 2 minus 200 e power minus 10 t 1 by 440 d by dv. Well, this is the value of voltage equation. 180 plus 20 e power minus t minus 200 e power minus 10 t. Now simplify this. 1 by 180 plus 20 okay, this is no simplification, but here differentiation with respect to one time differentiation is there. Okay, differentiate this equation. Okay, so actually d by dt. Okay, see here d by dt is there. See, by mistake I wrote here d by dt, d by dv. Okay, d by dt, differentiate with respect to time. So 1 by 40, this as it is. So constant 0, e power minus t is minus 1 into e power minus t, minus 20 e power minus t, and this become minus 10. Minus 10 into 200 is 200 into 10, you will get that much value. Okay, means 2000 e power minus 10t. Now ai value, see ai value is, you in the entire equation you group all constant. 180 by 40 is the only constant left out, that is 4.5. And bi, okay, bi is e power minus t, you group all e power minus t terms. E power minus t, e power minus t, group all the terms. So here 20 by 40 minus here 20 by 440. What is that? That is group of e power minus t. By doing all that, we get a coefficient 5 by 11. Okay, 5 by 11. So that value will be 0.454. Again ci, now group all minus 10 power t terms. Minus 200 divided by 40 plus into plus 2000 by 440. What is that power? E power minus 10t. Even that becomes minus 5 by 11. That is minus 0.454. So therefore, I return all the constants here. Enter these values in the assignment. Okay, got it? So method of solving is so like this only, but you should be you should do once again cross check if I made any mistakes in substituting the values, so that you can submit your own calculated answers. Okay, method of solving only I can give guarantee. Okay, even I might also get a same proper values, but like this, if I do some silly mistakes, d by dv, I wrote d by dv, now it is d by dt. So 20 e power minus t. While simplification, I will take minus 2t. Something if I done such silly mistakes, so you can go through once. Okay, that is about first problem. Next, second problem. So plus 2 minus 12 volts. This is 2 Henry. T equals to 0. Switch is closed. I1 of t, I2 of t. 12 ohm and 8 ohm. The above circuit was in a steady state before the switch was closed at t equals to 0. For t greater than 0, the current I1 of t and I2 of t can be expressed as. For t greater than 0, they given I1 of t and I2 of t equations. A1 plus B1 e power minus K1t, A2 plus B2 e power minus K2t, where K1, K2 are the roots, where t in seconds. Let apply KCL at this node. Okay, some I of t current passing here. Okay, parallel circuit. If switch is closed, this two become parallel. So I can write I of t is equal to I1 of t plus I2 of t. Okay, now what is I of 0? So I'm finding initial and final value. I of 0. I of 0 is voltage by resistance, because they given here the circuit was in steady state before switch was closed. Steady state means inductor is short circuit. So this becomes short circuit. Voltage by resistance is the actual current. Okay, 12 by 12 is 1 ampere. Now I of infinite. So final value in steady state, final value is what? Infinity. So now what is the current, supply current now? See, now 12 and 8 both are in parallel. Okay, 12 and 8 both are in parallel. So voltage by this parallel combination of the resistance, that gives the value of current, that is 2.5 ampere. So now actual I of t current is final value of current, that is I of infinite plus open bracket I of 0 minus I of infinity close bracket e power minus okay t by tau. So what is tau in an RL circuit? Tau is L by R. Okay, so now e power t by tau is there. So t by tau is what? L by R. So further this become RT by L. R by e power minus R by LT. What is the value of R? 12 and 8 are in parallel divided by L. Inductor value is 2. So all this simplification gives 12 parallel 8, okay, divided by 2, that gives minus 2.4 t, okay, minus is outside, so minus t. So initial value is 1 ampere, steady state value is 2.5 ampere, okay. So simplify this. I of t is equal to 2.5 minus 1 minus 2.5 is minus 1.5 e power minus 2.4 t. This is actual I of t value, but what I need I1 of t and I2 of t, that is in this format. So now I1 of t, just use the current division rule, okay, current division rule concept. So what is current passing in this resistor? Supply current into opposition resistance, other resistance divided by sum of the resistance. I of t into 8 divided by 12 plus 8. What is I of t? Enter this equation. 2.5 minus 1.5 e power minus 2.4 t into this entire value becomes 0.4. Multiply this with this. 2.5 into 0.4, you get a 1. Minus 1.5 into 0.4 minus 0.6 e to the power of minus 2.4 t. So 54 is 60. Yes, it's correct. Next, I2 of t. Current passing in this resistor is supply current into this resistance divided by sum of the resistance. Current division rule. I of t. Entire I of t equation into this entire fraction become 0.6. 2.5 into 0.6 is 1.5. Minus to this 1.5 into 0.6 is 0.9. E power minus 2.4 t. So therefore, see now I got I1 of t and I2 of t, the same format. A1, B1, K1 value. A2, B2, K2 value. So A1 is what? 1. What is B1 value? Minus 0.6. Okay, because they given plus B1. Next, what is K1? 2.4. K1 is 2.4. A2 is 1.5. B2 is minus 0.9 and K2 is minus 2.4. So like this, we completed second numerical. Same way, see this numerical and this numerical method of solving is same. See next question number 3. 10 volt is applied, 8 ohm I of t, 2 millifarad, t switch is closed at t equals 0, 8 millifarad V of t. The switch is closed at t equals to 0. Before that, the above circuit was in a steady state and the capacitor on the right side was uncharged. The capacitor on the right side was unchanged. For t greater than 0, the current I of t and voltage V of t can be expressed as, okay, I of t and V of t equations given here. AI plus BI e power minus t by tau, V of t AV plus BV e power minus t by tau, where t is in seconds. See, now look at here. When switch is closed, the two capacitors are in parallel, okay, is equivalent to, if I close the switch, these two will be in parallel. So in parallel, we can add the capacitance value, 2 milli plus 8 milli, 10 millifarads. But the total initial charge in two capacitor is, we know that charge is equal to Q is equal to CV. What is C? 2 millifarad. Okay, don't take 10 millifarad. Initial charge in the capacitor. Okay, initially the switch was open. Only this capacitor is going to be charged. Okay, therefore that's why I am considering only 2 milli into what is the voltage? 10. I got 20 millicoulombs. Now initial voltage after the switch is closed. Initial charge in the capacitor is this much only. Okay, in the capacitor, not in two capacitor, in the capacitor. Okay, initial charge means before switch was closed. But when switch is closed, the initial voltage after switch is closed is given as V of 0 is equal to, okay, charge by capacitance. Okay, Q is equal to CV, but V is equal to Q by C. So this formula is Q by C. What is Q? 20 millicoulombs. What is equivalent charge? See, when switch is closed, both the capacitance will be included. So that's why I written effective capacitance 10 millifarads. By that we got 2 volts. Now what is the current I of t? This voltage minus voltage at this point divided by resistance. 10 minus voltage at this point divided by resistance is I of t. So therefore I of t is equal to 10 minus V of t by 8. So now what is V of t? V of t is equal to, okay, so 10, that is the what initial value, okay, 10 plus 2 minus 10, okay, initial voltage is 2, final voltage will be 10 only, into e to the power of minus t by tau. What is tau in this circuit? R into C. Whenever inductor resistance is L by R, okay, that is tau. But here tau is RC only. What is the value of R? 8 ohm. What is C? Equivalent capacitance is 10 millifarads. So by doing this, we get v of t 10 minus 8 e power minus 12.5 t. Okay, this is the actual v of t equation. So now this becomes ab value, and this become bv, and this become a root value, okay, or the tau value, okay, tau or t by tau, something like that. So next, that is a root also. Next, I of t is equal to, according to that, I of t 10 minus v of t by 8. See how we got this according to this previous numerical, like this. V of t is equal to v infinite plus v of 0 minus v of infinity e power minus t by rc. Like that, you will get this one. Okay. Okay. 10 minus 10 into minus 8 e power minus 12.5 t divided by 8. So doing this, minus 10, minus to minus plus 8 e power minus 12.5 t divided by 8. Okay, 10 minus 10 is 0. 8 by 8 e power minus 12.5 t. So therefore current equation I of t is e power minus 12.5 t. So this we can write it as 0 plus e power minus 12.5 t. Okay. What is the question is given? AI. What is the value of AI? This is the value of AI 0. Okay. And the value of BI is 1. So AI is 0, BI is 1, AB is means voltage value, coefficient is 10, and BV is minus 8. Along with that, they also asked tau. What is tau? RC. R is 8 and C is C equivalent capacitance 10 power minus 3, 80 milliseconds. Okay. So thank you so much for watching the video. I hope so. I given a method of solving almost 100% correct, but you should be very careful while copying all this, whether I taken the same values in the question, that you should take care. Okay. So have a nice day. Take care. Next we can meet on assignment 4 solutions. Please do like, share and subscribe our channel.